What's going on, everyone? Steven here, back with a new video for you. Before I jump in, just want to let you know that this Saturday, May 26th, 2018, at 6 p.m. Eastern Standard Time, I'm going to be live streaming on my Twitch channel. The topic will be how to create your own free cam / fly cam in a video game. I'm going to be using the game Painkiller Black Edition. I know that there's a newer remake of Painkiller, but that's not the one I'm going to be using. I'm going to use the original. And, a fly cam is when you can basically unlock the camera from the player or detach it and then move that camera all around in the environment wherever you want. So we're going to start from scratch, and I will show you how to create that. Yeah, head on over to twitch.tv/sneakymofo, and that's 34 instead of EA. And I'll have a link in the description below. You can tap or click that as well. And if you want to, go ahead and follow me so that you'll see whenever I go live. And yeah, just looking forward to actually hopping in there and interacting with people and, just doing something a little more free form, because I'm so busy these days that I don't get around to making videos. Plus, I'm not the biggest fan of YouTube as a platform for creators at the moment with all the craziness going on. So I'm not really incentivized much in life to use YouTube. So I'd like to get going with Twitch finally. So come on over, and every 2 weeks I'm going to be doing a live stream. So it might become more frequent than that, but I figure that'll be a good initial commitment. So hope to see you there. Alright, with that said, I'm going to get started here. In this video, I'm playing Megadimension Neptunia VII. Now, this game is meant to be played with a controller. It does have mouse and keyboard controls, but with the mouse, you cannot invert the controls, which drives me absolutely bonkers. So, I wanted to do something about that, and now I'm going to share with you how you can too. This is very easy in this game. I don't know if it's going to be the same in other games, because games are rarely one-to-one unless you're in the same engine that the game was made with, blah blah blah. But anyway, so now if you see here, move the camera around, move the camera up and down. Alright, so up and down movement is called pitch. This is a camera's pitch. This is yaw, Y-A-W. Pitch, vertical movement, yaw, horizontal movement. Okay? So, with a combination of those things, you can move your camera all around. What we're going to do is look for pitch first, the value of pitch. Now you see how I can only go this high and this low, right? This is called clamping, camera clamping. So this is a clamped range that keeps me from going higher or lower. Typically, what clamping is good for, a lot of games you'll notice you can move all the way up to the top of the avatar's head, or all the way down to the bottom of their feet. Or if you're in first-person mode, you can look straight up at the sky and straight down at the ground. Okay, that's typically a range of 90 degrees. So, well, 180 total. But usually if you're looking at the horizon, 0, looking straight up will be plus 90 or 90 degrees or 1 radian, or just below that, so like 89.9 whatever degrees, and then 0.998887 radians, whatever. And then looking down will be negative. It's some variation in there, okay? So typically when you're looking for these values, it'll look one of two ways. It'll look like radians or degrees. Degrees will be a bigger number, like 0 to 80 something, whereas radians will be like 0 to 1 or 0 to 6, something like that. Anyway, I'm going to get into a lot more of that with the live stream, so if that's all going over your head, don't worry. Alright, so we want to make it to where, you see my mouse pointer on the screen. Hopefully it's showing on the screen. When I move the pointer up, it pushes the camera where it's looking down. So the camera moves up, but it's looking down, right? If I move this down, it moves the camera down and you're looking up. This seems intuitive as I'm explaining it, but if you set this up in a first-person game that you're used to, it's backwards. This is backwards. So is this. I'm moving my pointer to the right, the camera is moving right. I move back to the left, the camera moves left. That is also not what I want. So I want the opposite of both of these things, right? So the first thing I'm going to do is attach cheat engine. Okay. And these values are floats like 99.9% of the time of any of the games I've done. Okay, and we're going to start for an unknown initial value while our camera is as high as we can move, like place it. Okay, so I think I've got it there. Do a first scan of unknown initial value. Okay, now I've got hotkey set. I'll move the camera down a little bit. Changed value scan. Move it again. Changed value, unchanged. Do a bunch of unchanged here. Okay, move it down, changed. Right now it's unchanged, 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 unchanged. Oh my gosh, I'm an idiot. I have this attached to cheat engine. Good grief. This is another reason I haven't been doing videos lately, because work is so busy and my brain is fried. I'm going to leave this in this video. Just to show, man. Like, I'll tell you what, my brain right now. New scan. How about we attach it to the video game, right? Megadimension. There we go. Okay. Let's try this again. Move the camera all the way up. Let's see. I'm going to do float, unknown initial value, first scan. Okay. Move it down a little bit. Changed value. There we go. Thought those results looked a little odd. Move it again. Changed value, unchanged. I'm going to sit here and hold unchanged. Look how many values are being whittled away there next to found. Typically, as long as I'm decreasing it by 500 to 1,000, every scan here, every cycle of this, I'll just let it keep on going. Okay. Alright, I'm going to move it a little bit and do changed. Now unchanged. Alright, now I'm going to move the camera all the way back up to the top. Okay, so this is presumably the same value as our first scan. So now I can go in here and say compare to first scan. Alright, unchanged value. Because our first scan, we scanned for the camera value where it is now. So let's compare these results to that scan. Next, unchanged. Okay. I'm going to move the camera. We're going to go changed. Do it again. Do it again. Alright, now I'm going to do changed again, because remember, we're comparing to the first scan result. So unless the camera is up here, anything else should be changed. Anywhere else we move it when we're comparing it to the first scan. Alright, so now I'm going to move the camera back up and like around here. Okay, and now I'm going to say unchanged. Alright, 340 results. That's getting to be good enough for me. Alright, so now what I'll do is, if I've got it down to this much, alright, first thing that I'll do is look for values that have an E. And if there are any that have an E, I'll get rid of those. Like this one, see this E? I will select a bunch of them and then remove selected addresses. And that's because whenever you bring down, like what we're going to be doing here is bringing down a bunch of values and toggling them. When you toggle values that have the E next to them, those tend to be addresses that, if toggled or locked, they'll crash your game, right? So for me, I like to get rid of all those. Alright, so a quick scan through the results here shows that I don't think any more have that E. I don't think 0 is going to be any of our values. Maybe it is. Maybe 0 is up high like this, but typically not. So what I can also do here is say compare to last scan, and then exact value is not 0. Next scan. Alright, so that got rid of a bunch of those zeros. Okay. So the first thing that I'm going to do is I'm looking through here and I'm going to see if any bigger numbers like this one, this 60 looks interesting. That could be where this camera is in degrees. All these other ones could be, that one could be a degree value. All these other ones look like they would be radians if they're it. Right? So what you can do is bring down everything. I'm going to create a header here. Right click and say create, or sorry. Well, wait, I guess I got to drag everything down into here first. Alright, once everything is down there, I can right click and say group config, hide children when deactivated. Sometimes if you've got a big project, a big game that you're doing a ton of stuff in and you're creating one big cheat table and you're looking for something like this, put all those values into a group and then you can hide them and name your group something like, cam, pitch, scan. Now I know this group has to do with values with that, right? So anyway, now what you can do is I'm going to select all of these, right click and toggle. You can also just hit space. Come back in the game, I'm going to try to move this down and look what's going on. It's not letting me. Cool, so that's, one of these values is the value I'm interested in. So now I'm going to scroll up to about halfway here. Hold shift, click here, hit space to toggle those. Now I'm going to try to move my mouse. I can. So that means these values that I just untoggled, one of those is the value I'm interested in. So I'm going to retoggle those, and all these I can delete. Right? So now what I'll do is I get to this sort of thing with this many, I'll start looking at the memory addresses, and I'm interested in like generally ranges, right? So here we see 1, 2, D. Let's keep looking at the 1, 2s. Let's see where that goes. Bunch of 1, 2s. Oh, here we go. There's a 1, 3 now. So these 1, 3s, right? And then it gets up to like 1, 4, 1, 7, blah, blah, blah. And I'll start chunking away like that. So this 1, 3 and 1, 2, I'm going to select all those, toggle them. Let's see what happens here. All right. Still locked, so all of these that we just toggled, we'll delete those because we know those aren't it. Alright, so now this 1, 4 range, let's untoggle those. Let's see what happens. Alright, we can move it up and down, so our value is one of those. So now we can trash these. I guess I didn't move that one up. Alright, let's lock that, see what happens. That's not it. Let's lock this one. That's the one. I can get rid of that. I can call this pitch. Alright, so now what we can do is basically inverting means what? You're going to have it do the opposite of what it's doing, right? So that's what we want to do. We want, presumably, to have the value written to this address be the opposite of what's currently being written. Whatever that means, right? So, we still have it locked here. Alright. Let's right-click here and say, find out what writes to this address. Alright. We have two things writing to the address. Let's stop that. Alright, let's go show disassembler. And here, this is what's writing. Okay. So I'm going to click off of this instruction so that you can really see it, because you can't really see that red on the blue. XMM0, whatever is in XMM0 is being written to here, right? So first, if we go replace with code that does nothing and come back in here, let's see what happens. I can't move it up and down. Perfect. So out of those two instructions that are writing, we can find out later if we want what that second one is, because we don't know. We just know that right now this is the one that appears to be the one we're interested in. I'm going to restore with original code. This instruction above is adding something, a value in XMM2 to XMM0, right? Before XMM0 is then moved into our memory address where pitch, the value of pitch is. right? So here, look at this, move into XMM0. Look at this. This ESI plus offset 198 is exactly the same here. So this is moving the current value of pitch into XMM0. The value in XMM2 is being added to that, and then boom, it's being written back here. So presumably whatever's being added to XMM0, hopefully if we reverse this instruction, we will invert what's written here. And if we want, we can backtrace, we can read up through here and find out how the value in XMM2 is derived or calculated, right? You can do all that if you want. You may have to do something like this. But what we're going to try to do is just make this a sub instead of an add. So right now if I move this down, right, I'm moving my mouse down, that moves the camera down. Moving my pointer up, that moves the camera up. Let's do sub. Click here. Okay, moving the mouse down is now moving the camera up. You know, the actual camera is moving up. The view moves down. Now the view is moving up. Down, up, right? This is what I want. This is what I'm used to. Alright. Now I still have this whole left-right thing that's still backwards. I want to change that as well. Cool, easy enough, we're going to get to that. Watch these bytes here. See how this is sub SS? F3, 0F, 5C, C2. Let's change it back to add and let's see which of these bytes happen to change and what it changes to. Alright, click OK. 5C changed to 5.8. So if we want this to be a sub, we're going to change this 5.8 byte to 5C. Okay, cool deal. Tools, auto assemble. Okay, we don't need to do an AOB scan because we can just reference this memory address, right? This offset from the base module and change the bytes there. But what I like to do is have a snapshot of code. No matter what I'm doing, these days I like to have a snapshot of my code so that if the game updates or something, hopefully I can reference something if an AOB scan breaks or whatever else, right? So I'll still do AOB injection here and just click OK, OK. We get this nice little snippet of code at the bottom, right? So I'm going to keep that. I don't need any of this. I don't need this. All right. I'm going to move this to show the instruction that I'm actually doing something with. It's this one. And then what I like to do is change this to something that means something to me. So I'll say pitch. This is pitch, right? And now what we want to do is get rid of these other bytes. All right, F30F58C2, that is this, right? That's the instruction. This is it in byte form. We're going to copy this, put it here. All right, so at this location, declare these bytes whenever we disable the script. When we enable the script, we wanted what? 5C. So when we enable the script, this will become sub instead of add. And once we disable it, it'll be add. We can get rid of these things too. Okay, so now we should go File, Assign to Current Cheat Table. Close that. We'll call this mouse invert. So if I enable it, let's see if this add SS changes to sub. It does. Back to add sub, add sub, add sub. Cool. All right. So now we want to do yaw as well. How can we do that? Well, typically, I'd say a good 99% of the time, yaw is 4 bytes away from pitch. So we can right-click on pitch and go browse this memory region. We can change this view here, the display type, to float. And this 6.07, that is our pitch value. So typically right here will be yaw. It might be one above. It might be 8 bytes over instead. It may be however many. Typically it's in the same sort of structure that you find your way into though. Okay. So one little trick that we can do is just keep this up down here. I'm going to click off of that thing. And now let's move our camera left and right and see what we see. See those? There's 3 values changing, but generally the 2 that are changing the most and the quickest are right there beside each other. Those are presumably, where the second one is yaw, we know this one is our pitch. So here we can right click and go add this address to the list, call it yaw. You know, if we want, we can create a script to inject probably here on the right, where we can then move the value of ESI here into a memory address that we allocate. So we create our own pointer to the base of the structure, which we can then reference this offset 198 and then offset 19C to have pitch and yaw when we restart the game. But that's something that we will delve into in the live stream. So we have our yaw here. I'm going to right click on this value. Well, first let's toggle it, make sure that yes, that's it. So now what I want to do is right click on here and say find what writes to the address. Alright, we have those 2 instructions again, interestingly. This one here, let's try that first one, just like we did with the last one. Show disassembler. Go up 1. Here, look, we have kind of the same thing. We have this add instruction that's moving XMM1, or adding, I'm sorry, XMM1 with XMM0, and then moving that back into here after that value is first loaded into XMM0. Same looking deal, man. We know exactly what's going on here. So we will just make this one nice tidy script. Alright, bring that up. I'm going to go Tools, Auto Assemble, Template, AOB injection, okay. I just want that snippet of code again. This is what just, you know, you don't have to do this. This is just something I like to do these days. Call this yaw. Alright. And this is the instruction. Oh, actually, you know what? That's not the one I wanted to inject on. Not a big deal. It's okay. We can just, since this add one is the one that we presumably want to do it with, I'll just cut, paste that there, cut, and then paste. There we go. That's going to be the one that we want to do what we want to do with. Okay, so let's copy that. And let's come over here, do this, DB, alright, we'll copy that whole thing, come here, and that 8, we're going to make it a C again, you know, because we did it up here, we know the add sub, that's the thing that changes. Before it was moving, or it was adding with XMM0, it was in XMM2. Now it's XMM1 with this one, so look, C2, C1, presumably these are referencing the XMM registers with the bytes here, but anyway. Okay, so this is looking pretty good, and if we want, we can say, like, you know, invert pitch. There we go. Invert yaw. Alright. And now we can say OK, because we were just changing a script that we already had added there. Okay, that's looking pretty good. We'll say OK. If I enable this script, let's see what happens with this add SS. Cool, it's sub. Alright, so now I'm going to invert this. I'm going to go in the game and see what happens. Perfect. This is the way I would expect to be able to move my mouse to look at all the things I want to look at. Right? So I have successfully inverted mouse. You know, and it was relatively simple in this, right? So long as you can kind of read assembly and sort of understand what's going on. Now there's something else I kind of want to change that I'll show you real quick, and that is clamping. I think I discussed clamping at the beginning of this video. I've tried doing this video one other time, I think. And anyway, basically clamping is a min and max range on the pitch, right? So I can't move the camera any higher than this. I can't move it any lower than this. It's a clamped range. Usually you can move it up like over the top of the character's head or down to their feet. If you're in first person mode, it's the equivalent of looking straight up at the sky, straight down at the ground. Usually though, those values are clamped, because if I'm moving this camera up and I keep going up, 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 you eventually move to the front of the character, but they'll be upside down, right? Like imagine you're holding a camera behind and you're moving it over someone's head and over to their face. Suddenly it's upside down unless you flip your arm, your wrist, you know, you flip it over so the orientation is correct. Alright, so that's clamping, helps you avoid that, as well as something called gimbal lock, which don't worry about all that for now. You can look it up if you want. Gimbal lock. Anyway, we want to find this thing that's enforcing the clamping, because I want to move as high and low as I want. Right? So now what I can do is here with pitch again, I'm going to see what writes to the address. Okay. So sometimes it's a read, sometimes it's a write. Sometimes there's a read on the value here because it'll read that value and then it'll go through some other subroutine that says, hey, is this value at the max or the min range? If it is, then sorry, you can't move any higher or lower, right? So that could be a read, to read the value to then go into that whole subroutine. But then there might be a write, where this write is writing the value, and then if I'm too high or too low, this will write what should be written. Right? So that's kind of how it can go. So for this, since we already know what this instruction does, I'm going to go to this one and go show disassembler. Alright. So now what you can do is if I try to replace with code that does nothing, let's see what happens here. Alright, so it's doing this weird funky thing that's not quite what I want, right? So I'm going to restore with original code. Alright. What if I try to start going down here and trying things after that write? So what if I replace with code that does nothing here? Nothing's happening. Okay, that could be a good thing. I'm going to restore that. What if I replace with code that does nothing on this call? Okay. Look at this. You see how the camera's bouncing more instead of just sitting there? That can mean that we're on the right path. Like the value isn't writing as quickly as it was before at the max and min range, but it's still being enforced. Alright, so let's see. We'll restore that. So that's what happens with that call. Well, what happens if we modify like the write to our address as well as this call or something like that, right? Replace with code that does nothing, replace with code that does nothing. So basically I see this call happening here after the write happens. And I'm just interested if we get rid of stuff, you know, basically getting rid of code, certain instructions, what's going to happen? This is a lot of trial and error, by the way. So I'm going to try this. And look at this. So I can move that camera as high and low. See how it's upside down now? This is why it's clamped. So I can't do that. Right? Cool. So now that we have that, right, now we know what we need to do. So if I restore with original code, what happens now? Same thing. Let's try replace with code that does nothing on this one and see what happens. Still acting funky. Alright. So, you know, I can go through and break and trace or just read up through the code and try to figure out why this works exactly the way it does. But typically there's something close by a call or a compare or something like that somewhere. Like maybe there's another compare or there's a jump up here that we could NOP, or see how this says jump if not above. We could change that to jump if above, or just JMP to always jump. You know, there's a bunch of different approaches, but for what we want to do right now, we know this works. Right, so I can just tools, auto assemble, template AOB injection. Okay, okay. Again, we're not going to do an AOB injection because we know what we want to do. We're just knopping bytes. So we can get rid of all that. Get rid of that. And this is where we want to make our injection. Okay. And since we're going to do all of these bytes, I'm just going to select all those, right-click here, and say copy to clipboard, bytes only. Okay. I'm going to put that here. Those are all the bytes. So I'm going to copy this, paste it here, and now these bytes and these bytes are the ones that we want to NOP. So F3, we'll just go from here over to F3, and then we'll just do NOPs until that even back out here. You know what I mean? So now F3 through 2, 4, we're not worried about. So then these 1, 2, 3, 4, 5, right? Okay. And now I can do that, and let's see. It is these bytes, right? Through 0, 8. Oh, I selected the wrong one. So it's through the move SS, right? No, that's right. We're good. Okay. Sorry, I'm just getting things kind of backwards here. All right, so anyway, we're good there. I'm going to say this was what? Unclamp. Unclamp range, or let's say pitch range. Cool. So now we say file assign to current cheat table, and we'll say unclamp pitch. Alright, and now if I enable that, we see the NOPs, we see that. Let's see if it works. It does work. Alright, so now what we can do is, alright, cool. We're good there. And now what you could do is create your own clamped range. You know, let's say you wanted to be able to go to here and here, right? Well, we could look at this pitch number, 4.7, and then down here it's like 7.4, right? And what you could do is create a script that will write, let's just do this real quick, why not? So we know this one here, let's show disassembler. Oops, I had minimized it so it's here. We know that this is what writes. So what we want to do is we will do an AOB injection on this. So we'll go Tools, Auto Assemble, Template AOB Injection. Okay, and we'll call this cam rotation scan. All right. Get rid of that. Keep that AOB. Do global alloc. We'll call this pitch, and we'll say 4 here. All right. And then we'll go pitch DD0, right? So basically we've allocated 4 bytes to hold the value, to hold the address that the structure the base of this structure, whatever this is, where pitch is, right? And then we initialize that whenever we enable the script. And now what we can do is, since we know that this only writes to one address, we don't need to do any compares, to find the right value or reference to be written. So we can just say move into pitch ESI. All right, so it'll move that into, we're creating our own pointer basically to the same structure. All right, and we don't need to worry about anything else for the moment. Now we can say file assigned to current sheet table, and we will call this camera rotation. And now we can add address manually, and we'll say pitch plus 198. That's going to be pitch float. I shouldn't have called that pitch. I meant to say like rotation or something. But anyway, it's fine. We'll just keep it pitch. No, we won't. We're going to keep it ROT for rotation. ROT. ROT. There we go. Because we also want to add yaw, right? So I'm going to change this to ROT. And this is pitch. Okay. And actually now I'm going to do assign to current sheet table because I didn't close this and reopen it, so it just has execute instead of OK. So now I'm going to call this camera rotation, move this here, delete that one. Alright, and then we'll Control C, Control V, enter, and we're going to name this one yaw, and we're going to do offset 19C, OK. So now when we enable this, and we come back into the game here, we move around, look at those values. Look at those beautiful values. Alright, so now we can get rid of this. And all of these things we will have for whenever we restart the game. And you could save the script and whatever else, right? But now what we want to do, we're going to create our own clamped range. Alright, so I'm just going to open this and go File, New Window. Alright, we're going to do a little Lua thing here. This is something I've already written. I'm just going to explain it here as I do it. So this is Lua. This tells Cheat Engine that when we enable this, treat everything in enable and disable sections as Lua, right? So the first thing that we want to do is set max and min variables / values, right? And so we'll do a local variable max equals, okay, so the highest we want to be able to move the camera is, let's say like there, let's say like 4.8, right? I'm looking at the pitch, the value right now when we've got it up here. So we're going to say 4.8, local min equals, let's see here, 7 point, I'm just kind of looking at the sky right now. Let's say 7.8. Did 4.8, we'll do 7.8. 7.8. Okay, and then what we need to do is we're going to make a loop. All right, this loop is going to continuously watch our pitch memory address. All right, and we're going to check the value. And if the value is at a certain min or max, then we're going to do things accordingly, right? So I'm going to say function, function loop. Okay, we'll say end, because you need to have that. And then I will, space, let's create a variable here called pitch equals, and then we'll do read float, and then we'll do pitch plus 198, because that was our, rot for rotate. rotate plus offset 198. So it's going to read the float in this memory address, right, which is our pointer that we've created to this same memory address here, all right, and it's going to put that in this variable called pitch, right? So now what I want to do is if pitch, right, is less than max, all right, so if pitch is less than max, so if the number here is less than 4.8, so if it's 4.7, whatever, if it tries to get below 4.8, right, that's what we're doing, then write float, let's do ROT plus 198 max, and then we will end, right? So if pitch is less than max, we're going to write max. Okay, so that will be the number that will be written if we try to go beyond that number, lower than it. Okay, so now what we can do is basically the opposite for min. All right, if pitch is greater than min, then we'll write min to there. Okay, so we've got that, and now we just need to set up all the stuff for the loop. All right, so this will be like timer related stuff. We can just say like t create timer. Actually, this is a little bit that I'm going to copy and paste, thanks to Sunbeam, by the way, for one of his scripts that had some stuff like this in it that I totally copped because it's easier. And then what we can do is in the disable section we can say timer, or timer underscore set enabled t false. Alright, so this is all that we need for the timer to run and to check our pitch and hopefully write the values accordingly if we're higher or lower than. So I'm going to file assign to current cheat table, and we'll say cam clamp. All right. So let's come in the game here. I haven't enabled it. We're moving freely still. All right. So now I'm going to enable this. Come back in the game, and let's see what happens. Look at that. It's being clamped. So no matter where we moved, the clamp applies. It's still doing the bouncy thing. So you can maybe try increasing when the loop happens to get rid of that. I'm not worried about all that right now. But anyway, there we go. I've done with this camera stuff that I wanted to do to, you know, really enhance the playability of this game for me, controls-wise. All right. So hopefully you enjoyed that. Again, come to the live stream on Saturday if you're seeing this video in time. I'm going to be just spending 4 or 5 hours or so doing a game where we're just hammering away at camera stuff and talking about it, right? So, yeah. Anyway, I hope you enjoyed this video. Hope you had some fun. Feel free to leave some comments below. Give me a like. Subscribe if you're not subscribed yet. And I will just talk to you all in the next video. All right? Take care.